Okay. So this is what your normal graph would look like, right? So if you remember yesterday's data set, right? We had those numbers, and if you remember, our median mode was same in that Excel,
Yeah.
right? So it was same because we had taken normal data. Okay, so in normal data, remember, mean median mode will be at same point. Okay, and as you go away from mean or median or mode, because this is all these are same in normal graph, the number of occurrences of values will be diminishing, right? So mode, right? Mode means what? Maximum number of maximum occurrence of number. So a number will occur multiple times when you are in the middle. As you go away, see this bar. So this is called your histogram. This represents your histogram. What does histogram talks about? Your histogram on x-axis will have the data, and on the y-axis, it's a y-axis is the number of times that values are repeating, isn't it?
Yeah.
So this is what you will have on this. Okay. So maybe I should talk about one example before I come here. Okay. So just give me one second. I'll open another document, another example. We'll do one example first, and then we'll come back to this. Okay. Okay. Going to new share. Okay, I'll explain you the problem. It might be difficult for you to read the font. Okay. What it says is, okay, you are, let's say, a marketing manager of a telephone company, okay, telephone provider, right? Like AT&T and things like that.
Yeah.
So, yeah. So now you are looking at, you have selected 200 customers and you want to look at their billing, okay, long distance or international call billing, okay, and you want to make some decisions on it, okay. So you have this 200 data set, 200 numbers. Now, of course, it is difficult to analyze 200 numbers, isn't it? Okay, even if you um, put it in increasing or decreasing order, it might be difficult because it's not possible to look at 200 things and then make some analysis. So when you have this kind of data, okay, and here you have only one type of data, right? You don't have two type of data, one type of data. So the best thing is to convert into histogram. Histogram will tell us, will show us the distribution of data. Okay, so this is what this talks about. So now what we do is we create a histogram. How do we create a histogram? We have n number of subscribers, okay, and what you do is you look at the largest and the smallest bill value. So largest is about 119. So let's say we'll round it off to 120. And smallest observation is $0, right? So from $120 or $0 to $120, that's the range of values that you have. Okay. Now I need to sorry.
So the
Highest is $120, right? You can see. Sorry, what did you say?
Yeah, I see it.
Okay, okay. Okay, I think I'm kind of losing your voice. It's coming and going.
Is it good now?
Yes, yes, much better. Yes. Okay. So I was saying that 120. Okay, you have 120. Now, when you are converting, now see 200 data, as I said, it's not possible to visualize. Okay. So you need to reduce it down. Reduce it, okay, to how much? That's the question. Okay. Anything less than 5, 6 will be too less data to visualize. Okay. Anything less than anything less than 5, 6 it's like you are packing too much of data into um each of those, and it becomes difficult to kind of um,
Yeah. So you can make bins.
make some analysis, isn't it?
Yeah.
Right? And more than 15 is generally too much. So what we do is we try to keep it around 10 bars. I know when you look at Power BI or Tableau, it is good that you create those 100, 200 well bars. But
Yeah.
when you have one single data to analyze, 200 bars or 5 bars doesn't say much. So in histogram, generally, okay, we create about 10. So when I say 10, it could be 8, 10, or 12. So when you have 200 data, okay, you need to create equal interval. So if you see this example, okay, there are some calculations, but don't go by these calculations. What it means is, I just want to have about 10, 8 to 12, somewhere around 8 to 12 number of bars.
Mhm.
So when you have data ranging from 0 to 120, okay, you have to divide this into those interval, right?
Okay.
Now, so this 8 to 12, this will help you to okay, decide what should be the interval. Now, for example, if I take 10 as interval, so 0 to 10, 10 to 20, 20 to 30, 30 to 40, we end up getting about 12 bars,
Mhm.
right? Because 0 to 120 is about 12. And 12 is also okay. So you can create a bar of, you can take an interval of 10 also. You
Mhm.
can do 20 also. 0 to 20, 0 to 20 to 40, 40 to 60. That will come around 6, half of 12, right? So again, 6 will be too less, right? So probably, um, interval of 15 is good. 0 to 15, 15 to 30, 30 to 45. So that all the numbers will be covered within, about 8. Yeah, about
Yeah.
8 bars. Okay. So we create this limit, lower limit, upper limit. Okay. Now, see, these things are done automatically by your Tableau or Power BI, right? Here we are doing it manually just to understand how they work, how they do it. Okay.
Yeah.
So, you end up creating this limit, and now you count the number of observation in each of these range.
Mhm.
You look at the number of observation in each of those range. So, if you look at the data set, of course, we have calculated and put it here. So you have 71 values between 0 and
Zero.
15.
Yeah.
0 to 15 has 71, 15 to 30,
37.
right. Okay. And then 30 to 40. Okay. And now when you have, so this frequency is your Y value. The
Mhm.
height of bar is dictated by this frequency. And on your x-axis, you have the interval of data, right? 0 to 15, 15 to 30, so on.
Yeah.
Okay. So this is discrete value. That's why you get a bar. If you convert it to continuous, if you make it continuous, you'll get a line curve basically, right? So we end up getting this curve. Okay. So this okay. So the curve that I showed you would look something like this. But let's talk about this example first, and then we'll go back there. Okay. So now we know how to create histogram, right?
Mhm.
The next part is you draw the histogram. You got it. Okay. But how do you interpret it? What does that mean for business? What does that mean for you? Right? So it says that, okay, you can divide this. Now we are interpreting it. Visualization is done, right? So we are
Yeah.
interpreting the analytics part or the visualization part after drawing the visualization. So if you see
Okay.
here, okay, you can see about three groups of values here,
Mhm.
isn't it? Okay.
Yes.
On left side are maximum people. So about if you say from 0 to 30, okay, they are about 71 plus 3708, more than 50% data.
Mhm. Hello.
Yeah. You see that more than
Yeah.
50% of data is between 0 to 30,
Yeah.
right? Can you hear me?
Yeah, I can hear you.
Okay. So there are more than 50% data on left hand side, right? Between 0 to 30.
Yeah.
Then, on the right side, if you see, there are about 30%.
Yes.
And about 20% data in middle.
Yeah.
So this is what this graph says. Now, what does that mean for you? What do you want to do? If you look at this graph, okay, what
Mhm.
action will you take on this? Okay. So the answer is, okay, it depends upon the the problem that you're looking at, right? The same graph of a retail would mean maybe different for a for this kind of business. It could be different, right? So if you in telephone company, okay, what they try to do is, see, they make money if you stay with them, right? And
Mhm.
if you change the provider, they lose business, isn't it? And
Yeah.
if you look at um, the services, almost everybody is providing same kind of service,
Mhm.
isn't it? It's not that,
Yes.
okay, this service is better, so even if the cost is high, I'm going to stick with that provider. No,
Mhm.
right? More or less, everybody has same kind of service, right? They are
Yes.
equally good or equally bad. Sometimes,
Mhm.
one network will get, sometimes other network may not come, but some other place, reverse might happen, right? So there's not much for them to compete on quality in the sense. They can only
Mhm.
compete on the cost factor, whichever
Yeah.
will give you less cost, right? The
Mhm.
you will go with them, right? Isn't it?
Yes.
So if you look at um, this data, okay, about 30% people have a higher incoming bills, right?
Mhm.
Now, as a business manager, for you, these 30% people are like a risk. Why? They might leave. Now, if some other provider tells them that, you come to us and we give you a lower bill, you get your bill will be reduced, okay, or maybe they are not thinking about the bill, okay, and once they realize that they are paying more to you, they will definitely leave and go, right? So these
Mhm.
30% that on the right side, they are like risk, okay. Tomorrow, if somebody comes up with a better plan for them, okay, they will go from you, right? You will lose 30% of your customers. That's a big chunk, right?
Yeah.
So what happens? You start coming up with new offerings for them. Okay.
Mhm.
You want to give a new offering so that you want to reduce their bill. You want to move the people on the right side to left side. Okay.
Mhm.
In this case, okay, this particular problem, you would want to move from right to left, not vice versa.
Okay.
Correct?
Yeah.
Why? Because you know
When you say right, it's the um higher bills, right? From 90 to 120.
exactly. And if they realize one day, okay, gone. Right?
Mhm.
Now let's assume that this is a graph for retail company. You
Mhm.
are a retailer, it could be Tesco or Walmart, whatever you think you are. And let's say you think that these are the bills of your customers. right? So you see that 30% of customers are creating a bill more than $90 to $120. Now, in a retail setup, the higher makes sense for you. As a Walmart, as a Tesco, you want people to buy more from you,
Yeah.
isn't it?
So you want to like move 15 to 30 into that higher buying.
Exactly. So for you, it's a problem because 50% customers have a lower value.
Yeah.
See, the main problem in retail is going to the store. How do they get you to the store? And
Yeah.
now you are saying that, oh, you have come to the store, but you're not buying. That's the worst thing that can happen, isn't
Yeah.
it? So what we are doing here is we are okay. So when you go there, right, they give you buy this, get that free, right? They'll tell you, discount if you buy two, correct? You buy this and you get other thing free. The reason they are doing it is they want you to spend more and more. Even if it is for them less profit, that's okay. But they want, because see, you need 10 things. Let's say, for example, if you don't buy those 10 things from me, okay, you'll buy from somewhere else. So why not create a situation where you buy all the 10 things from me, right?
Yeah.
Okay. So they try, their strategy, if you see, is always okay to spend more. Okay, if you buy two, the profit for them will come down definitely. If you buy one, let's say it is $50. If you buy three, it is $100. So saying buy two, get one free.
Yeah.
Definitely they are losing $50. But instead of 50, they are making you shop for 100. That's what they want. They want more people to come. They want to. So you understand, right? For retail, they are looking at these leftmost people and how do they move to the middle.
Yeah.
And for a telecom provider, your problem is reverse. You want to bring those rightmost to the middle because they are the risk. They will go away. So depending upon your business problem, your objective will definitely change. Okay. So this is how you can draw a histogram, and this is what histogram talks about. Now let's go back to our theory discussion. So we said that we look at the middle one. Okay, I'll talk about other two in some time. So you have this normal graph which has mean, median, mode. Same as you go further away, the count in normal situation. Let's say if you talk about height of a person, right? So you'll find more people around average height. Very tall people will be very less. Very short people will also be very less, isn't it?
Yeah.
Right? So that's why you see the end will always be smaller and the center will be always bigger. Okay, in normal. Okay, but we have other cases also, right? Now, so this is called perfectly symmetrical distribution or normal distribution or no skewed, zero skewed. Now, let's take an example on the left side first. So if you see this left side, okay, you have a normal graph, okay, where it's like, let me take it in a paint and show you. Just give me a second.
Okay.
Okay. You should be able to see the paint.
Yeah, I
Okay.
can.
So I'm talking about this graph now. If you look
Yeah.
at this graph, it looks like as if, somebody has taken this and stretched towards left, isn't it?
Oh,
That's what it looks like, isn't it?
yeah.
Somebody has, you know, caught hold of this point and stretches towards left.
Okay.
So this situation will come when you add outliers on the left side. So yesterday we added outliers on the right side, higher values. If you add a lower value, that means your mean is around 50 or let's say 500 and you're adding 5 or your average, your mean is around 50 and you're adding 0.1, 0.2. So last time we added 500, right? That higher value. So went on right side. Now you're adding 0.1, 0.2, which is on the left side. So those are your outliers, right? So when you add outliers towards left, this is how your graph would change its look. Mode will not change. That's what we saw,
Yeah.
right? So when we
Mhm.
added outliers, mode did not change, right? What changed? What? Mean and median both? Which
Yes.
ran faster?
Mean.
Mean ran faster. So you see what happened? Median is on the left and mean is on the left of median,
Mhm.
much further away from me mode. That's what we saw, right? Median will move slightly towards left, but mean will run towards left.
Yeah.
That's what we saw yesterday.
Mhm.
Now look at the C, the third graph here. Somebody is holding this and pulling it.
Yeah.
Okay. So what happened? That means you're adding outliers on the right hand side, higher values. You're adding outliers on the right hand side, higher values. So when
Mhm.
you add outliers on the right hand side, mean will run more towards right hand side. Exactly what happened yesterday.
Yeah.
Okay. The side towards which the tail is there, the mean will run in that side. Okay. So your skewness, okay, depends upon which side you have outliers or which side you have tail. Okay. Now, if you draw XY coordinate, right? The right side of X is positive side, isn't it? Left side of X is negative,
Mhm.
right? So if you look at X-axis, this is positive X, right? And when you draw this coordinate, right? This side is negative X, isn't it?
Mhm.
Correct?
Yeah.
So when this tail is going, which side tail is going? Tail is going towards positive x-axis. Which side tail is going? Which side you are adding outliers?
Mhm.
Positive side. So you're adding tail on the positive side. It is positively skewed graph. Your
Okay.
tail is going minus x side. It's going towards minus x, minus x, minus x. We call it
Mhm.
as negatively skewed graph. So you have positively skewed graph, negatively skewed graph. If it is normal, good. If it is not normal, it has to be either positively skewed or negatively skewed. I'm not going into calculations, okay? We would never calculate. You'll have any formula to do that, okay? So let's understand the concept, okay? So if you come here, this is what this explains, and this is the formula. Xi minus x bar cube by ns cube, okay, where s is the sample standard deviation of xi and x bar of xi, and xi is the arithmetic mean, okay, and x bar is the sample mean, arithmetic mean, okay, and data is your xi. So sigma means you have to minus each and every value, right? So if you have 10 values, you're doing first value minus average of the values, second value minus average of the values, third value minus average. That's what sigma xi minus x bar means. X bar is mean, xi is each of the values. Okay. And you do, and you're doing the cube of those.
Okay.
Okay. Sigma is stands for summation. So you will add each of those. So first value minus average cube plus second value minus average cube plus third value minus mean. Okay. Average cube plus. Okay. And you add all of them and divide by ns cube. And is number, s is the standard deviation. This is how you calculate your skewness. Okay, so
Mhm.
if skewness is more than zero, we say positively skewed. If skewness is less than zero, we say negatively skewed. Positively skewed means tail is going in positive x side. Negatively skewed means tail is going on the negative x-axis.
Okay.
What? How to calculate skewness. Perfect. So this is all what we discussed is your part of which one? Central tendency. Okay.
Okay.
Now, now let's say, okay, I say that our class will start at, let's say, 10 p.m. Okay, let's say I tell you that. We'll have class at 10 p.m. Now, one day I'm logging at 9 p.m. Other day I'm logging at 11 p.m. Okay, some days I log in earlier at 9 o'clock, I take classes. Okay,
Mhm.
you are not there, you come at 10 and you realize that class is almost done. Other
Okay.
days you keep logging in. I join late. I come at 11. It's almost for time you to wrap up, but I start the class then.
Mhm.
Are you going to like it?
No.
Why? I'll say, see the average of 9 and 11 is what? 10. And our
Mhm.
time is at 10. Okay. So average is important, but average alone cannot tell you how good the data is, isn't it?
Okay. Mhm.
So average is important, obviously. Okay, and so far we were talking only about average or median. Both are same, right? In a way, in terms of significance, that's what we saw. Not the formula wise, but
Yeah.
significance wise, both are same.
Mhm.
And we saw when to use which one. Okay, but when that itself, mean or median alone is not enough, because I can tell you, see, the average is perfect 10, and that is our time to start. So I'll keep coming at 9 o'clock and 11 o'clock. No. You also have to look at range. How much is the difference between maximum value and the minimum value? Okay. You need mean. Mean has to be 10. But also, see, mean means what? You'll have values higher, you'll have values lower. So if I tell you mean is 10, it means there are some values more than 10, there are some values more than less than 10 also.
Mhm.
Okay, but the question comes here is how much more, how much less?
Mhm.
Okay, that's what range is. The first metric talks about range. Range talks about the higher value in the group minus the lowest value in the group. Okay, sometimes, okay, or many a times, if you see, higher range is not a good sign.
Mhm.
Okay, if range was zero, that means what? High and low is same.
Yeah. So there's just one value.
Sorry, where is the one value?
If the range is 0.
Huh. So no, values can be more. It's all like 10, 10, 10, 10, 10, 10, 10, 10, 10. Maximum is also 10, minimum is also 10. Everything is 10, 10, 10, 10. Okay. That is the best thing that can happen. But that doesn't happen always, right? It is
Mhm.
possible that you will be late sometimes and sometimes you will be early. So
Mhm.
idea is try to be less early, try to be less late. It's not perfect. 10 o'clock you click a button. That doesn't happen in life, isn't it? At exact 10 o'clock you click and the meeting starts. Right?
Mhm.
Sometimes, okay, I log in and it is early. Sometimes I log in and maybe a minute late, a minute, 2 minutes late. So range tells you how good is your process. Mean
Mhm.
tell you about the value that can represent your process, but ranged will tell you that how good or how predictable is your process. Okay, lower the variability, higher is the prediction. Right? So let's say if I take this data 1 and data 2, right? Data 1 range is 100 minus 5, 95. And data 2 range is 100 minus 21, 79. Which has highest range? Data 1 has highest range. Now you tell me, is it good or bad?
Highest range is bad.
Mm-hmm. Right? Okay, good. High range is bad, okay? Because example of 8 o'clock and 10, 11 o'clock, high range is 2 hours, 3 hours, not good, right? Our class itself is 1 hour. How can you be late by 1 hour, right? Or early by 1 hour? Okay.
Yeah.
Now, but sometimes there will be outliers. Okay, sometimes I might have meetings, sometimes there could be some other thing. Okay, possible that we are late. I tell you, okay, I'll be 50, half an hour late. Okay, please join after half an hour. Possible, right? Now, those things, if you add them, okay, outliers means very less occurrences, rare of rare cases. So now just because there is one outlier, let's say you start and one day I come 1 hour late for some reason, okay?
Mhm.
Now, so range is always about maximum minus minimum, isn't it?
Mhm.
So always whenever you calculate range, you will always get access higher value as that outlier. Even though I came only 1 day at that time, okay? But every time I talk about high, you're talking about that value.
Mhm.
So sometimes, okay, range may not be good. You understood when, right?
Mhm.
Okay. Range may not be good because one bad thing will spoil your data. Every day
Yeah.
you did great job, but one day you got delayed. Range will always capture your minimum and maximum. It captured your maximum saying you were doing wrong. No,
Yeah.
right? So, 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 so we say that okay, fine, okay. We will not look at all the data. Okay, but I know the data could be biased, could be error. Okay, there could be outliers. Okay, and because of which the range may not give us a good estimate. So I will not go with range. Instead, I'll go with interquartile range.
Okay.
Interquartile range. Okay, inter means within, right? So leave out inter. Quartile range. Quarter. First, you need to figure out what are quarters. What is a quarter? 1 by 4.
Yeah.
That means if you talk about one scale or one river or one something which has a spread, let's say, okay,
Mhm.
and and you want to divide the data set into 4 types.
Mhm.
Who divides the data set? Among the things that we have discussed in the last 2, 3 days. What is division?
Mhm. You're asking me.
Yes. So what is that dividing into 2 part?
I did the data.
Median. Median.
Yeah, the
Remember?
median.
So what
Mhm.
happens? Median divides the data set into 2 parts. So when I say
Mhm.
quartile and I want to divide data set into 4 parts, I will find median of median. So let's say if your data set range from 5 to 500,
Mhm.
and you said, okay, I'm going to find the middle value, exactly middle value, which will give me median 1.
Yeah, median too.
Okay. And here also it will try to do the second partition. Okay. And so this is your minimum value, right? Here you have 5. So minimum value. This is your median. This is your median minimum value. This is your maximum value, and this is your median value. That's what medium does. Now, if we divide this, if you take this as one data set and find the middle value of this, and find the middle value of this, okay. So when you divide the data set into 2 parts, we call it as quartile. Quartile. Okay,
Okay.
per quarter. Quartile means per quarter, per 1/4. So you're dividing data set into median by half, and then again you're finding median on first half as well as second half. So you get four quarters, quartiles. Okay. Now we know this is minimum. This we know this is maximum. This is middle median. This is called as quartile one, Q1. This is so you can call it quartile zero here. Minimum value is also called as quartile zero. If I give you the 10 data set, 10 data, with 10 values, and if I tell you what is the quartile zero value, so to find quartile, percentile, um, all this style, okay, you have to have in median, you have to have in increasing order, isn't it?
Yeah.
So first you have to arrange the numbers in the increasing order. And the lowest value is called your quartile zero.
Mm-hmm.
And this 25th one, number that divides into 1, 4 exactly is called quartile 1. Quartile 0, quartile 1. This median is also called as quartile 2. Exactly same meaning. Median or quartile 2. Okay? So you do that. Now, okay, so this is this is also called as quartile 2. Your median is also called as quartile 2. This is your quartile 3. And this is your quartile 4. This is called as quartile 4. Okay. So data set, minimum value is called quartile 0. The number that divides in 25th portion is called 1/4 is called quartile 1. Then you have quartile 2, quartile 3, and quartile 4. Now, will you hear about percentile? Right? When you write GMAT or any of those exams, you get percentile. Percentile means per 100. That means you're dividing data into 100 parts.
Mm-hmm.
Okay, and then you say my percentile is 99. That means there is, okay, you divided data into 100 percentile, 100 groups, and yours is at 99. That means 1% people is above you.
Yeah. Hello.
Yes, yes. Okay. So when I say percentile, that means 99 percentile, that means 1% person is above you. Right? Okay. So what we do is the discussion why we went to quartile is you have to first calculate the quartile, and for IQR, what is IQR? Interquartile range,
Okay. Interquartile range.
right? Okay. So interquartile range, okay, is the value that should be displayed when you so let's say outliers. Outliers will be on the extreme end, isn't it?
Yes. Yeah.
Okay.
Q0 and Q4.
Correct. So, somewhere here will be your outliers, and somewhere here will be outliers, correct?
Yes.
So in IQR, you say that you are doing Q3 minus Q1.
Yeah.
Okay. Q3 minus Q1 will give you the range of values. Now, if you do one or twice, okay, mistake, it will ignore it. Okay, it's outlier. Rarely he's doing it, so ignore.
So if that rate thing happened between Q1 and Q2, then
What thing happened between
yeah,
Q2?
yeah. Like anyways, the outliers will be at the
Exactly. Okay, we'll be at the ends, not in Q3, Q4, Q2,
yeah.
Q4. So we create, okay, a mechanism, okay, to ignore this outliers, and of course you can have your own data and your analysis, things like that.
Yeah, got it.
Okay, perfect. So now let's go back to our discussion. Okay, this
So
is
all this we are going through is related to statistics, is it?
yeah, yeah,
Yeah. No. I just wanted to. Yeah, I got it.
yes, yes. Okay, so we are finding IQR range and IQR.
Yeah.
Okay, So IQR is another important metric to find your mean, sorry, not mean, range and IQR, percentile, quartile, things like that.
Mhm.
Okay, because you need to do a little more work on it. You have to remove the outliers.
Mhm.
Okay, that's one job, and this talks about how to perform our steps. You can read it. It does the same way. Okay, just that it has explanation. Okay. Now, when you have IQR, when you have Q0, Q1, Q2, Q3, Q4, you can represent the data as a box plot. What you see is called box plot.
The
Okay.
first diagram where it
Yes.
says inter quartile range. Okay.
Correct. Okay. So now if you do this, okay, so it could be sleeping. So you will have box with a cut here. Okay, and then you have two handles.
Yeah. So those two handles are Q0 to Q1 and Q3 to Q4.
Exact. This is your Q naught, minimum value. This is
I've
Q1.
said box
Sorry?
plot, but I never really understood.
Yes. So this is how actually the box plot are drawn from your data set. Okay.
Okay.
Also remember, box plot is the only plot which will specifically mark outliers for you. So when you
Okay.
do a box plot, sometimes you might have dots here.
Yeah.
These dots are called as outliers.
Okay.
Okay, outliers, because those, and this is under, this, the calculation, okay, has done it. We are not doing it anything. Okay, so, okay, box plot is the only plot which will specifically say this is outlier.
Mm-hmm.
Okay. Horizontal, the histogram will create tails. So by looking at it, these are outliers, but it is
Yeah.
not sorting and telling you this is an outlier.
Yeah.
Whatever number is there, it will adapt to that number, adopt to that number,
Mm-hmm.
right? Okay. So this is what we say, IQR, or sorry, not IQR, the box plot. And box plot will have minimum values. Handle is the minimum value. This is your maximum value. You can only draw box plot on a numeric data, not on any other data. You can't draw it on a complex, um, text data. You can't draw, right? Because you need to arrange in increasing
Sales,
order.
right? So
Sorry?
can we put on sales and profit?
Yes, you can do that.
So sales per category.
Ah, now sales per category ultimately will result into a number, right? Sales. So you can obviously do. So you'll have multiple box plot.
Mm-hmm.
Okay, so if you have 10 categories, you will get a 10 box plot. If you're doing on sales, you get only one box plot. If you're doing on category, you will get number of categories. Okay, if 10 categories, you give you 10.
Yeah, each of them will have a box
Yes.
plot.
And then you can, in analysis, you can say what do you see from, or are they different? Okay.
Yeah.
Okay. So this is your median, or Q2. Q2 is also same as median.
Mm.
Q1 and Q2. Okay. And you can have a standing box plot also. Need not be always sleeping.
Yeah. In Tableau, I've used like the standing box plot. I've seen that.
Exactly. Yes. What are the important? So scatter plot, box plot, histogram. These three are very important. Okay. I don't think you'll have any complete dashboard without this graph. Okay. Perfect. So this is how it is showing relationship between skewness and the graph.
Okay.
So You do IQR so that you are removing the outliers. See, this is another box plot. So total bills amount by day of the week. If you go out for eating dinner, this is how
Mhm.
much you will spend on each of the days. Thursday, Friday, Saturday, Sunday is what you're looking at.
On an average, you would spend around 10 to 20 on Thursdays, and Saturdays you spend around somewhere between 14 to like 25, right? Am I interpreting?
But
Yeah.
also look at the
Outside, there are exceptions. Some days you did spend 40, somewhere between 40 to 50 on a Saturday, but those are not often. They're very rare.
right. So now you're whatever you're talking about based on the median only or mean only, right? Median only basically here.
Median, yes.
Yeah. But you're
And the
not
line in the between for like everything, it's showing up a line. So on Thursdays, so what is that line? So I mean I understood that it's from
median.
Q.
Median is the center line, right? So which line
Oh,
you're talking
okay.
about?
The median value, and it's considering even the outliers for the median value. Yes.
Correct. Right? The range is
So
also higher when you go Saturday and
we're
Sunday.
looking on Saturday, so the median is somewhere around 18. So it's also considering the outliers for that median.
Correct.
Okay.
Okay. Okay. You can learn how to draw these. What is quintiles, deciles? Decile is per 10. Quintile is per 5.
Mm-hmm.
If you divide line into 5, how do you handle it? Okay. It's called quintile. We saw how to handle um, quartile. Same way you do it for 5, 10, 100, whatever. Okay, so quickly let's jump over. Okay, so with those two, okay, we also have something called a deviation and variance. Okay,
Okay.
so let's look at that example how to calculate. I want to show you how to do it so that you will remember ever, right? You will not forget. Um, Excel. I'll open an Excel. Okay. Now let's say I run a business of car distribution. Okay, I have a showroom. Okay, and you come, you customers come and buys car from me. So from date of making your first payment to the date of delivery.
Mhm.
Okay, from the date of making first payment to the date of delivery, how many days does it take?
Okay.
Okay, so let's say I looked at you looked at data for today. Let's say today what I did, I gave first car when that had come 10 days before,
Mhm.
6 days, 19 days, okay, 4 days, 1 day, okay, 14 days, 15 days, okay, 7 18 days. Let's say these are the days. Today I we
First
three.
order and the day it's been shipped from today.
Yes. So these are 8 cards I shipped or I gave. And these are the people who had gave me or booked the car these many days before.
Yeah.
10, 6, 9, 4, 1, 14, 15, 18.
Hmm.
Okay. Now if I try to find average. Now I want to know how good is the process.
Mhm.
How good is the process? So obviously you find the average, right? So let's say average equal to. So first you always take average, okay? Okay. So what did I do? I just added them, I guess.
Yeah, you just
Right?
add some of, yeah.
And then you divide by, okay, I
Divide by
could have done direct average, but let's say, I'm trying to be smart, but I couldn't. So your average is 10.8.
yeah.
Average is 10.8. But how do I know whether I have done good or bad? Okay. So one way is that you minus let's say what I'll do is I'll somehow reduce it to make it exact 10. Okay. Let's say I give 10. Perfect. Okay. So that it is easy for to talk about. Okay.
Okay.
So you get average 10. Now what I'll do is to know how good is the process, I will divide this actual value with 10. Okay. So this is the actual delivery date and this is your promised date or expected value.
Mm-hmm.
You promise for 10 days. Okay. We also call it as expected value.
Mm-hmm.
Okay. Okay. Now you will say 10 minus 10. Okay. Now next what I'll do is C2 needs to be fixed. So I am fixing it. C2 needs to be fixed. So
B,
function F4 you say. Okay. Now you directly you hit. Okay. So these are dates. Okay. Now you see this car was delivered 4 days before time.
mm-hmm.
9 days after time, 6 days before time, 9 days before time, 4 days after time, 5 days after time, 1 day after time.
Mm-hmm.
Now you tell me how good is the process. Okay. So first thing is you find all this and then you find the average value. See, these are values for each value, right? And if I need to find for all, I need to D12, D11. Okay. So I need to find the average of all the delays or the early or late, whatever you call it. So what do you get? You get answer as 0. This is what I told you. Okay.
Mm-hmm.
One day I'm coming 1 hour early, other day I'm coming 1 hour late. Plus 1 hour minus 1 hour, 0. So it says that your process has no deviation. Is it true?
No.
No. Your process clearly has deviation. You see, there's 0 also, there's plus 9 also, there's minus 9 also.
Yeah.
That means every values, okay, is repeating, kind of.
Yeah. If we remove the outliers here,
How do you know which is outlier? You don't know yet.
I mean, yeah, the max and the min, yeah. Yeah.
Okay. Okay. So this is not a good way because if you do average, you're getting 0. So what we do is another way is okay, saying okay, delay is a delay. Whether you come 1 hour early or 1 hour late, why should I say -1 or +1? Delay, okay, whether you come before also, it's a problem for me. Come after also, it's problem for me.
Yeah.
Okay. So you will say, okay, we call it as absolute difference. This is difference.
Yeah.
This we say absolute difference. Absolute difference is finding value with, okay, absolute value. That means all negative numbers should be convert it into positive. This is 0, but this becomes 4, 9, 6, 9, 4, 5, 1. Okay. So when you find the absolute difference, then you find the average. Okay. So your average value, you should treat it as 4.75. That's your average mean. Okay. Where you have considered the deviation also other side. Okay. So you get almost same, right? Similar data you get. Okay. So this is your difference. And you can use, this is called absolute difference. This is called median. So mean absolute difference.
So
Math.
what does the number 4.75 mean? I mean, are we
Average,
saying?
average. Average of all these values, isn't it? Same
Yeah,
thing,
yeah.
average.
I mean,
Average.
I got it. It's an average of
Average of absolute difference.
yeah. So I
It is
mean, what do we
by math.
understand from the data
So
is my
this
question.
is one number which will show you the how much process is deviating.
What do we mean by process deviating? I
See,
didn't get.
you expect 10, but you don't get 10, you get 6, you get 19, you get 4. See,
Yeah.
you expect your class to start at 10 o'clock, but it's starting at 9 o'clock, 11 o'clock, 9 o'clock, 11 o'clock,
Mm-hmm.
right? So you need to fix the process.
Mm-hmm.
Let's say you go and complain saying that class is not happening on time. So you need to fix the time, isn't it?
Yeah.
So you said, okay, fine, let's see the difference. So first you have to accept there is a deviation, isn't it?
Yeah.
If you simply add plus or minus, you get 0. This is what I told you. Deviation is
Yeah.
0. One day I'm starting 1 hour early, other day I'm starting 1 hour late. On average, it is 0. 0 deviation. I'm
Yeah.
not deviating. I'm starting correctly at 10 or 9 o'clock. Why? Minus plus you are cancelling and you are getting 0.
Yeah.
But reality is, whether it is 1 hour early or 1 hour late, I have 1 hour problem,
Mm-hmm.
isn't it?
Yeah.
So
Yeah.
you want to change the sign, whether early also 1, late also 1.
Mm-hmm.
Okay. Early is also 1, late is also 1. That means, okay, so this is probably the correct way to represent. And since we have different values, but I need to know the process, not individual. About the process, if you do, then you have to take average of it and you get 4.75. That's the average value. So you say mean absolute difference. On average, mean difference is about 4.75.
Okay.
Okay. So this is your mean absolute difference. This tells you mean deviation in your process. Okay. But okay, so this is good process. This is okay. Fine. So this is also acceptable value. Okay. But as statistician, we don't want to do something simple. We want to go do a little more complex. So what we do is, okay, I'm not going to do the absolute difference. To make it positive, I'm square the difference or difference square difference. So see, one way, see, I told you, right? Problem is -1 plus 1 will make it 0. So we don't want to do -1 plus 1. We have to make all plus. So one option to make plus is you find the absolute value. All the values become plus. Second option is you do square of the value to make it plus. So 0 becomes 0 and 4 becomes 4, 16. Okay.
Okay.
And now you say, okay, I'm going to do the average of this. But what is the problem here? problem is you have done the square. You have gone to different unit. Okay. You know, I'm talking about apple, you're talking about apple square. I'm talking about mango, you're talking about mango square. Right? We are in different plane now. Not correct.
Yes.
We have to be in the same
Same.
plane. Right? So say, okay, sorry, then let's do what? Let's do square root of this. Okay, we'll bring it down to the same unit. You started with the apple, how can it become banana, right? Or apple square? It has to apple only. So you go and do it. Okay. So this is what is called as variance in statistics. This is what we call as standard deviation. That's why we find square root of variance as standard deviation
Okay.
to bring it down to the same level. This is also called as mean squared difference.
Okay.
This is also called as root mean squared difference. Squared only, but we are doing the mean. Mean square difference, root mean square difference.
Okay.
Okay. And when we go to machine learning, we call this as error. Difference is your error. Okay. So this becomes mean squared error. You call this as root mean squared error. Okay. So this is how we calculate variance. And this is how we end up getting mean squared error or root mean squared error. Or here also we call this as MAE, mean absolute error. Okay. And all these errors, okay, all these errors are, okay, are the way we will evaluate the model later. Same formula, same concept, just that difference becomes error. That's it. In machine learning, it becomes error. In statistics, it is difference.
Okay.
Okay. So just remember this. This is how we are getting. So we are talking. See, we spoke about mean, fine, but we are not stopping at mean. We know the problem with mean, isn't it?
Yeah.
So we have to figure out: is there any other way which can go along with value to give us some credibility? So that's why people started discovering standard deviation, and you have a standard deviation. So every value will have a standard deviation, and you want to see if the standard deviation is right or not. Okay.
So what is that value 5.65? I'm just trying to
Standard
understand.
deviation, that is your standard deviation.
So are we saying that on an average, the estimated
Error,
base?
estimated difference is 5.6.
Okay.
So for every process, see, individually you have 10, difference of 0, difference of 4, 9, 6, 9, 4, 5, 1. This is individual difference. So again, but you need one number to tell you the whole story, isn't it?
Yeah.
How good is the data? You cannot say, okay, oh, data is a difference of 0, 4, 9, 13, 21, 25. No, on average, you'll say data is deviated by.
So it can go like 5.6 times less or higher than the average value.
Yes.
Okay.
Okay. And this concept, remember, when we do regression, we'll use same terminology, same word, and we're not going to discuss then.
Okay.
Okay, perfect. Coming back to our discussion. Now, if you see this graph, okay, all these graphs, these are normal only, right? All these are normal,
Yeah.
right? Because the mean
This
median mode looks same. Now you tell me what is the difference between these graphs? You have done 5 to 6 metric. What do you think will fit here?
what metric will fit here?
How are they different? Or how are they similar?
uh, 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 similar in the sense they're all symmetric.
Okay, so answer here is your mean median mode of all three are same. See, this is the tip here, this is the tip, this is the tip. And we said that normal graph, since all three are normal, we said that mean median mode of normal graph is same. So mean median mode of all three graphs are same. Difference is standard deviation. Thinner the graph, you have less standard deviation. Fatter the graph, you have more standard deviation. So leptokurtic is thin. That means leptokurtic graph, the
So when
thinner
you say
graph,
thin,
has the
like,
lowest standard deviation.
so when you say thin, like which one is the thin one here?
Leptokurtic, the tall.
Okay, okay, leptokurtic. So that's good data basically.
Okay. So yes, if you're talking about deviation, yes, we don't want deviation. So this is
Yeah.
the better one. Yes. Okay. And this is what we'll be talking about for the rest of the class. Okay. Okay. So this is what is the difference between mean, median, mode, variance, standard deviation. Okay. Your standard deviation. So mean again, we'll discuss about this mostly in the um, in the regression concept. Okay. What you also need to remember is, okay, this is the graph, for example, which, so here average is 100, here also average is 100, mean median mode is 100, okay, but median is, sorry, standard deviation is 15 here, and standard deviation is only 5 here. Okay. Now, one more thing that you have to remember is, and again, here in non-distribution is the area under the curve, okay, represents the total values. Area under the curve, total values is 100%, right? So total area under the curve will be 1 unit. And depending upon where you are, okay. So what it says is your 1 sigma, 1 standard deviation. Okay, zero, let's say 0 is mean, or mean is 100, or 0 is mean. Let's say in this case 0 is mean. If 0 is mean and you have calculated standard deviation as 5, so it says from 0 to 5, you will have
Yeah.
okay, and it says that area under the first and one standard deviation. So if standard deviation is 5, okay, that means plus 5 and minus 5.
Yeah.
Total area on the curve is about 68.2%.
Why 68.2%? Hello.
Okay, and the area under the curve for first standard deviation is 68%. Plus or minus 5 from 0 will have 68%. Remember this. From, okay, we'll talk more when you go to regression, but these numbers have to come, remember. Second standard deviation is 13 plus 13 plus 34 plus 34, which is almost like 95%. And within third standard deviation, you have 99.9, 99.7% data.
I think the screen is zoomed in. I don't really. Oh, okay. Yeah, I'm able to see it. So, so we're talking about the same graph, right?
Yes, yes.
Okay.
Okay. So, yes. And this is another thing. So standard deviation is the deviation process, right? And mean is getting that mean. So if you look at, we'll go from second value, or from second. Let's look at second first. When you look at second, it says dots are together, right? That means deviation is less. Yes, when you say deviation is less, dots will be farther, will be closer. So your deviation is linked to precise. Okay, when you say precise and accuracy, so there's a difference. Your standard deviation is linked to precise and your mean is led to accuracy. Second case, you see dots are all close together, very good. So that's why your data is precise. But expected was center, but your data is somewhere outside. You expected data to be here, but it is somewhere else. Okay, so we say it is not accurate. Okay, so it's like telling you we'll start class at 10 o'clock, but I always start at 11 o'clock, always, every day. So every day is 10 o'clock, no deviation. That means it is accurate, but it's not precise. Sorry, it is precise. Precise, okay, 11 o'clock, but it is not accurate. Okay, because I expected at 10, you're doing at 11. So it is not accurate, but it is precise. Third graph, you see, dots are everywhere, neither accurate nor precise. Do you say that? No, it is accurate. Okay, because average of dots, you see, it will hit the bullseye. Yes or no? Dots are equally spread around dot, equally spread around dot. So it's like 9, 9, 11, 9, 11, 9, 11. If you take average, it will be 10 only.
Yeah.
First one is what you want the process to be. Highly accurate and highly precise. Okay. But your graph can also be not accurate, not precise. That means, okay, average also if you take, it is not what you want. And dots are everywhere. Dots are everywhere, but when you want, you get access to it. That's your everywhere means not accurate. But what you want, you get precise. So not accurate and precise is what I'm talking about. Did you understand?
Yeah.
Okay. So we'll stop here. Okay. Tomorrow we'll talk about how to do visualization in R. Not tomorrow. Okay. We are not meeting for next 2 days. Then now we'll start with visualization and then we get into algorithms. While doing algorithms only, I will then explain statistics. Okay. So hopefully by Tuesday or Wednesday,